In this video, I'm going to explain how to interface LPC 1768 with a switch, and you can display its status through relay, buzzer and LED. So first let me show you, we are using in our college, we are using Vasundhara kit. So you can see there are 8 LEDs are there. So this is a port 0, this is a small LED. It is connected to the port 0.4. This LED is connected to the port 0.5. 0.6, 0.7, 0.8, 0.9, 10 and 11. So port 0.4 to 0.7, any LED you can check the, you can use it as an output device to check the status of the key pressed. So these are the push button you can see in the below. It's connected to the port 1 left side. Okay, left side there are 8 keypads are there. Okay, push button keypad. So left one is actually port 1 21 pin. Next to that is port 1 20th pin. Next is port 1 19th, 18th, 17th, 16th, 15th, and last right corner is port 1 14th pin. So 8 push button keys are there, 8 LEDs are there. We can use any of these keys and we can check the status of the key whether pressed or not by using buzzer or a LED or relay. This is a relay you can see here. So after this switch, last switch, push button, we have left side we have relay. Okay, it has connections, so no connection, no connection. Middle one is uh, connection. Okay, normally closed. NC means normally closed. NCO means normally closed. Okay, so this is a buzzer. Top right side you can see the buzzer. So this jumper should be at this position. If jumper is missing, sound will not come. So you should be careful. So there is a buzzer here. Okay, buzzer should be 3 buttons will be there, so it should be connected to the down too. Okay, now you can see the kit above the kit here. We also have the connection details. You can see the pin details here. Okay, so if you are in your college, if different pins are using, you have to use that one. See, your LEDs are connected to in our college kit. It's connected to the port 0.4, 0.5, 6, 7, port 0.11, and similarly keys. Okay, this one is X keypad. It is connected to the port 1.18, 19, this is 20, this is 21, 14. Key you can check where it is. So these are the keys. Okay, from 1.14 to 1.21. Okay, this is actually a T-class 3 row matrix. Okay, you can check other keys also. Similarly, you can see here relay. Relay is connected to the port number 025 pin. Port number 025 pin. Buzzer. Okay, buzzer is connected to the port number 325 pin. Okay, now we'll go to the program. I'm going to the first what we have to do. First you have to configure switch as input. Okay, switch as input. That means switch is connected to what? Switch is connected to, I'll show you the diagram. You have to configure switch as input. So this port 1.21, port 1 21st pin we have to configure as input, and this LED. Okay, this particular LED port 0.4 I have to configure as output. Okay, port number is 0, pin number is 4, here port number is 1, pin number is 21. So let us go to the program. Minute. Okay, this is the program. This is interface a simple switch using and display its status using only LED. Okay, so the diagram is, you can use the simple diagram. Okay, we are having only one simple. This is a interfacing diagram LPC 1768. port 1.21 is configured as an input device, you have to check the status of the key is pressed or not. If the key is pressed, then LED should turn on. If the key is relieved, LED should turn off. You see the connection here. Once it is pressed, it is connected to the ground. So this value becomes 0. And in the program, you have to make sure that whenever key is pressed, you have to set the port 0.4 pin. Okay, when it is not when it is pressed, we have to set the pin. When it is released, we have to clear this pin. Okay, now we'll go to the program. So I will show first this is a relay connection. Okay, this is a relay. NO means normally open, NC means normally closed, CO means common pin. Okay, pin number 1, 2, 3, 4, 5 is the connection. So now let us go to first we'll do configuration. Okay, first we'll do configuration. LPC underscore include LPC 17xx.h. We are including header file belongs to the 1700 17xx family because xx is in our case it is 668 1768. Int main open bracket and close bracket, open the bracket, LPC underscore GPIO general purpose input output, port number 0. This is port number 0. We are making FIO DIR fast input output direction is equal to we are making 1. Which bit? Fourth bit. We have to take a binary 1. Okay. Exaggerate 32 bit 1 and you have to left shift by 4. If you do that, exactly the fourth bit of port 0. This is port 0. Exactly this fourth bit will become 1. If you take 1 and left shift by 4, exactly the fourth pin. Okay, start from 0, 1, 2, 3, 4 pin becomes 0. Similarly, why you have to make 0 means in order to configure any port as output, okay, it should be have the value 1. Okay, 1 means output, 0 means input. Similarly, key is connected to the port 121st pin. Okay, this should be 0. 0 means input. Okay, LPC underscore GPIO 1 FIO DER. Okay, and is equal to this is complement of 1 left shift by 21. So first it will do 1 left shift by 21 means exactly 21 pin becomes 1. After that complement that 1. Complement means that first we set the 21st pin to 1, then we complement it, so that particular pin becomes now 0. So this is optional, and is equal to, here you have to use or is equal to vertical line. This is optional, you can without this also it will work. And one more thing I want to tell you here, when you reset a microcontroller, all the port pins are 0. So by default all the port pins, port 0, port 2, port 1, port 2, all the pins acts as input only. So that's why without this line also it will work. Okay, this line is also optional in this particular program because we are using only some 5-6 line now. Without this also it will work, but if you are writing some 100,000 lines in between, if you want to configure any pin as input, you have to use this format only. So next, while one means true, infinite times it will execute this. So open bracket, if this is a not symbol, not of LPC GPIO 1, okay, then FIO pin and with 1 left it by 21. That means port 1 21st pin. Okay, port 1 21st pin. It is going to read the value using FIO pin, and we are doing AND operation with 1. 21 bit is 1 now. 21 bit 1 value is ANDed with the pin value. The pin value here in the switch, if it is pressed, it is reading this pin value. If you press, this becomes 0 because it is directly connected to the 0. If I press short will take place and this pin value becomes 0. So that if you added with 21st pin 1, no, so 0 and 1 is 0. So and operation, if you press the key, FIO pin value becomes 0 because it is shorted to 0 ground, and 0 ended with 1 is also 0, and not of 0. There is a not in the here. This is exclamatory symbol, not of 0 is 1. So that means true. Not of false is true. So if true, you have to set if LPC GPIO port 0 FIO set which pin, fourth pin of port 0 we have to set. So and it is connected to the LED. In the diagram you can see it is connected to the LED, so it is going to glow. Else means FIO pin will be not connected to the ground, so it is open. So this is also 1. So 1 and 1 is 1 only, and not of 1 is 0. So it is going to what? So it is going to send FIO clear. So FIO GPIO 0, LPC GPIO 0, port 0, and fast input output clear. Which pin? Fourth pin. So if you send logic 0 to the port 0 fourth pin, that LED now it is turn off. So this in this way you can mm, check the status of uh, pin, whether pin is pressed or not. So how to verify the output? Press the button here. Immediately LED should turn on. If you release the button, LED should turn off because we used not off that. Okay. Similarly, here I will show. I'll upload the diagram also. Here, if I press this button, this LED will turn on. Down one. If you release, this will turn off. Similarly, if you want to configure port 0.5, so in the configuration port 0, that 4 you have to replace by 5. Okay. Similarly, if you want to configure, if you want to check using this port 0 11th pin, that is a top LED above one, then wherever 4 is there, replace by 11th pin. So same program now, if I press the key, it is going to change, this LED is going to turn on and off. Similarly, instead of 21st, this is the first key, you can check it, you can assign to this 20th pin or 19th or 18th, any one pin. So you change in the program, instead of 21, you change it to either 14 or 15, 16, 17, 18, 19, 20. Any pin you can use in your program. So this is how to check the status of key pressed with the help of LED. Same program I will convert this one to now with the relay. Okay, check the status of key pressed with the help of relay. So for that, relay is connected to, okay, relay is connected to port 0 25 pin. Okay, this is the relay. You can observe here port 0 25 pin. Okay, now this is port 0 25 pin. So same program you have to edit. Okay, what is the edit you have to make? You can note down. So here port 0.4 was connected to the LED now, down LED. So now we are using checking relay. So instead of 4, now you have to configure port 0 25th pin because port 0 25th is connected to the relay. So you have to remove the 4, type 25. Type 25. So that will make you port 0 25. That is relay pin which is connected to the relay is configured as output. Similarly, port 1 21st pin only we are making 0 complement. First set the value, then complement it. So port 1 21st pin, if you want you can change it to 20th pin or 90th pin or any pin. If you want you can change this 21 to that value. After that, while 1 not of LPC GPIO 0 FIO pin. Okay, we are checking 21st pin only in this one, port 025, whether it is that key is pressed or not. If it is pressed, if you want to check the relay, I told now wherever 4 is there, you replace by 25. This 4 replaced by 25, this 4 also replaced by 25, this 4 also replaced by 25, and execute. Now, if you, whenever you press the port 121st pin, the relay is going to uh, make connection and no connection. Okay, so that is about how to connect relay. Similarly, we can also check using buzzer. So there is a buzzer in the kit. So you can see here it is connected to the port 325 pin. Port 325 pin. So for this we already changed this one to in our program. Okay, in our program we already changed this one to port 025. Now in the previous program port 025 is for relay. Now this 0 you change it to 3. So GPIO 3 FIO DAR, one left it by 25. Now port 3, 25th is connected to, actually 25th pin will be 1 and it acts as a output. And again in this program also port 121 pin only we are configuring as an input, and we are checking that same pin is pressed or not. If it is pressed, what you have to make? Port 3, here you have to change port 3 25 pin. You have to set FIO set, and port 0, if it is clear, if it is not pressed, same port 3 you have to clear the 25th pin. So that time buzzer will stop. So the buzzer will make sound, beep sound when you press the button. Okay, when you press this button, then the buzzer will make a sound. Sometimes if sound is not coming, you check whether the buzzer is there or not. Sometimes buzzer is this by loose connection, this jumper may be not there, so you have to check. So you have to type the program. So this is the program. We have to create a new project. Okay, and add, right click and add new source item to the source. Add .c .c file. Give some name. Okay, switch something, and you type this. Okay, LPC GPIO 0, FIO 0, 1 left it by 4. So this is port 0 means you have to write port 0. Port 3, 25th pin means you have to type like this. This is for buzzer. Again FIO GPIO 1, FIO DIR not off, that is a complement of 1 left it by 21. The first pin, that is port 121st GPIO is actually we are checking. Okay, LPC GPIO 1, FIO pin value, you have to end with this value. If it is press, see if formula there are only one statement, there is only one statement, that's why after if there is a, you can omit this open bracket and close bracket between this. So directly you can write LPC GPIO pin number 3 and port number 0, port number 3, 25th pin you have to configure as high out, then buzzer will beep. Else LPC GPIO 3 you have to clear same pin, port 3, 25 pin. Okay, for LED port 0, fourth pin. Here also port 4, fourth pin. Port 0, fourth pin. For relay port 0, 25 pin. Port 0, 25 pin. Port 0, 25 pin. For buzzer port 3, 25 pin you have to use. And you can also write all in single program. Okay. So this is a single program where you can control all the switches of buzzer. Okay, buzzer, relay and delay, buzzer, relay and LED, everything you are checking in the single program. So you have to configure port 0, fourth pin and 25th pin in the single line. Configure port 0, fourth pin and 25th pin. You have to one left it by 4 or with, this is vertical line. So vertical line means you have to type shift, yeah, shift slash button, backslash button, and one left it by both 4 and 25th pin of port 0 is configured as input, and port 3, 25th pin is configured as output. Port 1, 21st pin is actually configured as input. So you have to check if the pin is pressed. If the port 1, 21st pin is pressed, then you have to set port 0, fourth pin, port 0, 25th pin. Similarly, port 3, 25th pin. Will make LED on. This will make relay on. This will make buzzer on. Else, you have to clear FIO clear, FIO clear. Port 0, fourth pin, port 0, 25 pin, port 3, 25 pin. So we are checking only one pin and we are turning all the three and we are turning all the off. You can also do exercise. You can assign one function for one. See, for example, port 1.21 you can check for with the help of LED. Next key port 120 you can use for check the status of key for display in buzzer, and one more for relay. So different pin for this. First you have to write if, next you have to write if else what you have to use. That program also you can do. So if the program, I think it is there, you can see. Check, you can try this. You can note down. You can try this program. Different pins. You can check it out. Okay, thank you. You refer another video for how to check the output also.